So really last generation of performance of regional trains, but powered by hydrogen without any CO2 emission. Last point, hydrogen trains for not electrified lines where electrification is really difficult for geographical constraints like tunnels, viaducts. So where electrification is not convenient, mostly in terms of economics.
Okay, thank you, Ilaria. So there are already hydrogen trains running. Yes. There are hydrogen trains under production, and we will see soon some of them even in our country, in Italy. But just to clarify for the audience, what to do with the hydrogen to reduce mobility. Basically, there are two different options. The first one is to transform hydrogen into electricity. This is what is known as a fuel cell. That is a well-established technology, and that is basically the idea to transform to use the transportation like an electric transformation. I think this is the case for the trains. So they are fully, let's say, electric trains, but instead of taking electricity from the line, they are transforming hydrogen into electricity. That basically is like a battery, but it is using as a fuel hydrogen. There is another option that is to use hydrogen inside of an internal combustion engine. So to burn hydrogen and then to use the, let's say, classical technology to produce mobility. Now, moving from the train, we are going to the trucks. And definitely trucks is looked as an option for hydrogen. There is a lot of, let's say, expectation for that. And we have here, a representative, Andrea, that is in a company that is very much, let's say, insisting and pushing in this direction. So, Andrea, please, what is the situation about trucks?
Thank you very much. Yes, I'm at FPT Industrial, so they're inside the Iveco Group, so we are in charge of the development of the propulsion system. And so maybe before focusing on hydrogen, it's worth to share some figures about what does it mean, the heavy-duty transport sector in Europe. So we are speaking more or less about 350,000 new truck registration each year. Today, still depending 96% on diesel. Where we see, of course, a larger differentiation looking to full electric, hybrid, etc., is the bus sector. On the truck sector, I will chase you because I would like to stretch the definition of hard to abate, because when you look to the contribution from the heavy-duty transport on the CO2 emission, you realize that 75–80% depends on the long-haul mission. So the truck running 700–800 kilometers, and where the capacity to have energy enough on board is key. And so here is, let me say, the hard aspect of this sector. So we need a lot of energy. Why we are still at 96%? Because of course the energy content of diesel, what you got from 300-liter diesel running for a truck 800 kilometers, you need an equivalent of 70–80 kilograms of hydrogen. Now translating into 2 cubic meter of storage at 700 bars. So this is, let me say, for our sector, is the first key concern. That does not mean that this will not fly, but this will, let me say, means that we will have to really work hand in hand with all the players contributing to create the right ecosystem, in particular the infrastructure system. But yes, you are right. There was, now it's I think 3–4 years, we had a revamp of interest about hydrogen, also in internal combustion engine, especially from the off-road sector. Now, quick move also from the on-road sector, so truck and bus sector, also because recently the Commission has rewarded hydrogen internal combustion engine among the solution for the zero-emission vehicle labeling, so at the same level as a full electric and a fuel cell one. So a lot of expectation, a lot of investment, but a lot of planet to align in the future. We can discuss further about.
Okay, thank you for providing already some numbers, okay? So you say we need a lot of energy, so we need a lot of hydrogen. You say that, roughly speaking, for running a bus or a truck, you need some tens of kilos, let's say 10, 20... Roughly 10 to 12 kilo for 100 kilometer. Okay.
You imagine that today the heavy-duty sector is consuming in Europe 100 million ton oil equivalent. So this is just to have a rough idea. It's nothing compared to the future overall production and consumption worldwide. So this is also another interesting aspect that we will not, let me say, drive the hydrogen economy as the transport sector as, let me say, we did maybe in the past with oil-derived products. But the mainstream, of course, will be on the energy sector also because of this new dimension of security of supply, of energy storage that you mentioned before. That is key overall.
Okay, so the idea is there is a consumption of hydrogen inside of the truck. The same will be in the train. We will come back on this, just looking back to the money. So how much is the cost of 1 kilo, just to compare, roughly speaking, what is the situation. But just, let's say, go on in the overview on what is running on in hydrogen mobility. We started from the train, then we moved to the truck. Now let's move to the cars, because, or at least to smaller, let's say, situations. So Gianmarco is from Dumarey, that is very much engaged in this hydrogen mobility at the car level. So Gianmarco, what is the situation about cars for hydrogen?
Yeah, thank you, Marcello, for the question. I'm very pleased to answer to this question because just to say 2 words about who I am and what our company is doing. Dumarey was formerly known as Punch, but even earlier was actually the engineering center of General Motors propulsion system in Europe. And as you may know, General Motors is one of the big OEM that invested quite a lot and is still investing a lot in fuel cell, hydrogen fuel cell. So we can say that we had a direct experience of hydrogen through our heritage from General Motors. And since 2020, when the engineering center in Torino, by the way, is located close to the Politecnico, so in the city center, we are roughly 700 people working on propulsion solutions there. I would say, starting from 2020, we work on hydrogen internal combustion engine. That was one of the vision of our founder, Mr. Dumarey. So I think that we can have a direct experience of both technologies, fuel cell and internal combustion engine, that are both 2 opportunities for smaller cars, or smaller vehicles compared to the one that we have discussed before, so trains and trucks. So we have seen recently a very increased interest in hydrogen also for smaller vehicles. For the same reason as said before, I mean, battery electric vehicles for sure are the solutions for the city, for mission profiles that are typical of urban mobility. But when we are going to higher loads, longer range, here is where hydrogen can be an interesting solution because overall we can be lighter than battery solutions. And if the cost and the availability of hydrogen will be there, could be also an interesting proposition from the total cost of ownership point of view. So there could be the question, so what is the winner, fuel cell or internal combustion engine in the light-duty space? And as usual, the answer is it depends, and depends on many factors. But typically, let's focus on three aspects that are efficiency, emissions, and total cost of ownership and cost. Efficiency, one could say the fuel cell tends to be recognized as higher efficiency compared to internal combustion engine. This is actually true if the load is not so high, so if the emission profile is in the low load or moderate load range. Where we are going to heavy loaded application, this is where the efficiency of internal combustion engine could be not that far from a fuel cell, so it could be an interesting proposition. In terms of emissions, with the optimization of combustion process after treatment, we can definitely say that a hydrogen engine could be not only by definition at zero emission, zero CO2 emission, but could also have criteria pollutants close to zero. So definitely will not be a problem to meet the Euro 7 with an hydrogen internal combustion engine. So also from emission perspective, it depends. Obviously, fuel cell doesn't need an after-treatment system. In certain application, hydrogen internal combustion engine requires an after-treatment system, so you need to have space. And for smaller vehicles, a fuel cell could have an advantage from that perspective. Finally, the cost. Currently, fuel cells are much more expensive than a hydrogen converted engine. And you have seen in our booth, we have a 6.6 liter hydrogen engine there. And the number of components that you need to replace compared to a conventional diesel engine are limited. We are talking about 20% of the components that needs to be changed. And the cost of a hydrogen engine is not far from the one from a conventional fuel, diesel or gasoline. Fuel cells are much more expensive from that perspective. So at the end, the total cost of ownership depends on the cost of hydrogen, on many factors, maintenance, and so on. But also in this case, depending on the emission profile, there could be advantage and pros and cons for both technologies. So overall, I think that we will see opportunities for both technologies in the future. So both fuel cell and internal combustion engines.
Okay, thank you very much for this message. In some sense, I think this is a quite positive message because, well, I was running in Europe on hydrogen in the last year, and frankly speaking, the idea to burn hydrogen was something that was very much rejected, at least up to, let's say, before COVID, let's say, some years ago. Nowadays, the mind has been slightly changed. I think the pushing companies is important to demonstrate that this can be an option. People is very much looking to that as a sort of intermediate solution to go to the fuel cell. But of course, at the end of the day, we will discuss later, people is looking how much it costs. So at the end, that is definitely a point. But we now have train, we have trucks, we have buses, we have cars. But because of this environment, we need to go inside of this train, trucks and cars, and just to look around about the components. How much is changing the components inside of a vehicle? And then I think we have